Section 8.5, partial fractions, linear and quadratic factors. We're going to look at just linear today. So the first thing you're going to have to do is decompose rational functions. So we know a rational function would be some function in terms of x divided by another function in terms of x. And what we want to do, decomposing, is basically separating them. Okay, so the first step, you're going to factor the denominator. Notice here both factors are linear. So when we decompose them, we separate them. So each fraction gets one of the factors. And now the numerator is some constant that we're going to find. So linear factors, we decompose them into fractions that have constant numerators. Okay, and again, we'll talk about finding them. So that's it. That's how you would decompose this. The next one, I have x minus 3 quantity cubed. Notice that this factor has a multiplicity of 3. So when we decompose it, each power of x needs to be represented. So a over x minus 3 plus b over x minus 3 squared, and then plus c over x minus 3 cubed. Okay, so decomposing rational functions. Factor the denominator if needed. That would be your first step. Then we decompose, we separate. And then, if need be, separate for each power of x. Okay, when I look at this, factor the denominator, x times x squared plus 10. So now notice I have one linear and one quadratic factor. So I still break it up. It'll be two fractions. My linear factor gets the a, just a constant term we're going to find. Now when I decompose quadratic factors, they get a linear numerator. Okay, so bx plus c. Again, you'll find out how to find a, b, and c. These first couple problems are just separating them into their decomposition. Okay, so this one, it's already in factored form. There's a linear and there's a quadratic factor, but the quadratic factor is a multiplicity of 2. So a over x plus my linear numerator, bx plus c over x squared plus 1. That's the first power of the factor. And then dx plus e over x squared plus 1 quantity squared. So every power of x needs to be represented, whether it is a quadratic factor or a linear factor. All right, and then the third type, so you'll see linear and quadratic factors, and then the third type of rational functions we could see is where the degree is numerator is greater than or equal to the degree of the denominator. So we start these decompositions by first dividing. So 2x cubed minus 4x squared minus 15x plus 5. 2x cubed divided by x squared gives me 2x. I multiply all of these. Then I subtract each term. Conveniently, the x squareds cancel as well, and I'm left with x plus 5. Okay, so this can't go any further. So this would be equal to 2x plus x plus 5 over my divisor. Now we can complete the steps to decompose this term. So this denominator factors x minus 4 times x plus 2. Negative 4 plus 2 gives me my negative 2. Negative 4 times 2 is negative 8. Both linear, so when I decompose it, it just gets the two constants. All right, so now let's look at using this to evaluate an integral. All right, first problem. Always start by factoring the denominator. So x plus 9 times x plus 2. The x plus 2 factors cancel, and now when I look at my integrand, 1 over x plus 9, it's just a simple log integral. So natural log of the absolute value of x plus 9 plus c. So remember, you're just learning a new technique, this partial fractions, in addition to parts and inverse trig. Doesn't mean that you're going to use it on every single problem we evaluate. Alright, so let's not rewrite it, let's factor it. So difference of perfect squares here. 2x plus 1 times 2x minus 1 dx. So that decomposes into a over 2x plus 1 plus b over 2x minus 1. So now let's talk about finding a and b. Alright, so a over 2x plus 1 plus b over 2x minus 1 equals my original. Alright, so first thing we're going to do, clear the fractions. So I'm going to multiply this entire equation by the common denominator, and I'm going to use the factored form because you'll see they cancel. So when I take my first term and I multiply it by the common denominator, I get a times the quantity 2x minus 1, b times the quantity 2x plus 1, and then it completely cancels the denominator from the original integrand. Alright, now finding the values of a and b when we have a linear of factors is very easy. We're just going to pick the value of x that would make each factor 0. So if I pick x is equal to a half, it eliminates the a term, and I get 2b equals 1. Half of 2 is 1. 1 plus 1 gives me my coefficient. So now I have b is equal to 1/2. Alright, so now let's eliminate the b term. The 0 there is negative half. Plugging in negative half here, I get negative 1 minus 1. So I get negative 2a equals 1. So it gives me a value of a as negative half. So now that I have my values for a and b, I can come back and plug them into my decomposition. So my value of a is negative half. So I have negative half over 2x plus 1 plus b is a half, 2x minus 1 dx. Now I'm going to separate these into two separate integrals just so you can see. Sometimes you're going to have to do this. So let me in fact take away those parentheses. The negative 1/2 can just be brought out front, and now this will be a u substitution. So if I make u 2x plus 1, du is going to be 2 dx. So I actually need another 1/2 out front, 1 over u du, plus 1/2. This will have the seemingly same u substitution. Another 1/2 out front to balance it. Then I have 1 over u du. Now each of these integrals are our log rule again. So my final answer, negative 1/4 natural log of the absolute value of 2x plus 1 plus 1/4 natural log of the absolute value of 2x minus 1 plus c. Okay, x cubed minus x plus 3 divided by x squared plus x minus 2. So before we can decompose this, we need to set up long division because the degree of the numerator is greater than or equal to the degree of the denominator. So x cubed, remember our rules. Every exponent needs to be represented, so I put a placeholder at 0x squared minus x plus 3. X cubed divided by x squared would give me x. So I get x cubed plus x squared minus 2x. Change my signs. So I get negative x squared plus x plus 3. Negative x squared divided by x squared gives me negative 1. Multiplying my divisor by negative 1, negative x squared minus x plus 2. Change my signs. and I get 2x plus 1. Okay, so this becomes, my original integrand now becomes x minus 1 plus 2x plus 1 divided by x squared plus x minus 2. Every single term can be integrated now. So, antiderivative of x, that's simple enough. I'm coming down here. X squared over 2. Antiderivative of negative 1 is minus x. Now let's look at this guy. We have all of these tools to be able to integrate. So instead of using partial fractions, let's see if a u substitution would work. U is equal to x squared plus x, which makes du 2x plus 1. Oh, hello. 2x plus 1 dx. That's exactly what I have here. So this will just simply become the antiderivative of 1 over u du. Another log rule. So then I have plus natural log of the absolute value of x squared plus x minus 2. Then I put my plus c there as well. Let me come back to this. I just saw I missed my minus 2 here, but it doesn't affect my derivative at all. So this one, again, you don't necessarily need partial fractions, but we did have to long divide so that we could simplify the integrand. Okay, let's set this one up. I don't know if we'll have time to finish it though. Start by factoring the denominator. So looking at this, let's see if factoring by grouping works. So the first two terms, x squared, I'm left with x plus 1. Now we know when we group, we want to make sure that the other factor has to be x plus 1 also. So what do I need to factor out of my next two terms? I'll take out a negative 1. So 4x squared divided by x squared minus 1 times x plus 1. And then lastly, let's difference of perfect squares here. X plus 1 times x minus 1. And then when I have my other x plus 1, it'll just give that factor a multiplicity of 2. Okay, so I have 4x squared divided by x plus 1 squared times x minus 1. So now when I decompose this, I actually have I'm going to have three fractions here. X plus 1, x plus 1 squared, because each power of x needs to be represented, and then my x minus 1. Okay, they're all linear factors, so those values will be a, b, and c. Let me multiply my entire equation by my common denominator. So I'll have 4x squared. Only one x plus 1 will cancel, so a times x plus 1. Next, my b will be multiplied by x minus 1. And then c, I'll have x plus 1 squared left. All right, for homework, I want you to attempt to find the values of a, b, and c. Substitute x is equal to negative 1, x is equal to 1. Get rid of that. And you can use any value of x. So the easiest one, x is equal to 0. That'll get you your third term.